sizes and different shapes. Depending upon the inspection requirement, the stylus is selected automatically. It is fixed to the probe head, and then measurement is carried out. Now, what are the features of coordinate measuring machine? Now, we can observe that a typical CMM is composed of three axes: x-axis, y-axis, and z-axis. These axes are orthogonal to each other in a typical three-dimensional coordinate system. To give maximum rigidity to the machines without excessive weight, all the moving members, that is bridge structure, z-axis carriage, and z columns, are made of hollow box construction. Each axis has a scale system, maybe a linear scale or rotary encoders, to indicate the location of that particular axis. The machine will read the input from the touch probe or mechanical probe or an optical probe as directed by the operator or CNC program. The machine then uses the XYZ coordinates of each of these points to determine size and position with micrometer precision. Now, air bearings are provided for ensuring friction-free travel. In these, compressed air is forced through a series of very small holes. For example, so we have a granite work table and then the column. So column, in the case of moving column type, column will be moving. So here air jets will be there. So I'll just enlarge this portion. This is the table surface and this is the bottom of column. So here small holes are provided through which compressed air is allowed to pass. So air will be escaping like this. So because of this arrangement, the columns will move frictionlessly. Optional rotary tables can be used to enhance the approachability of the measuring probe to complicated workpieces. In the case of advanced CMMs, they have their own computers with interactive dialog facility and friendly software so that the workpieces can be inspected with least effort. And then a map of systematic errors in machine is built up and fed into the computer system so that the error compensation is built up into the software. Various thermocouples are incorporated throughout the machine and interface with the computer for making the thermal compensation. If there is any variation in the temperature, the thermal compensation is provided by the software. Now, what are the different modes of operation? Now, CMMs are available which have manual mode, and in this case, it has a free floating probe. The operator moves the XYZ axis manually to establish contact with the part feature to be measured. The differences in scale readings among the contact points are then are the measurements. Now you can see in this particular picture the granite table and the workpiece, and then column, bridge, etc. Now you can see the operator is holding the probe head and he manipulates the probe. That means manually he moves the probe to make contact with the workpiece. For example, this is the probe, and then we have a workpiece which has a step like this. So the operator moves the probe and he makes contact with this particular surface, and he records what is the reading, and then he lifts the probe, and then it is moved in this direction, and again it is moved down, and again the contact is made between the probe and the workpiece surface. What is the reading is recorded, then the difference between these two readings is calculated, which will give what is the depth of this step. Like this, manually the probe is moved and contact is made with the workpiece feature, readings are recorded, and the required value is manually calculated. So this consumes a lot of time, and maybe operator may make some mistakes while calculating. And the advancement over manual mode is manual computer assisted mode. In this case, electronic digital displays are provided to CMM. We can observe here a monitor is provided which indicates the data points. So electronic digital displays are added to CMM for making zero setting to select the required system in system or metric system to print data in the standard format. These features, that is computer assistance, saves time, minimizes calculations, and reduces errors. Now we can also see this is shop floor CMM. You can see the CMM is mounted on this table which has wheels. So wherever measurement is required, we can move this coordinate measuring machine with the help of these wheels, and then the measurement can be made. Now let us watch a demonstration of a manual coordinate measuring machine which has a built-in electronic digital display. So in this demonstration we can see the CMM with X, Y, Z movements. The three movements are manual. That means the operator has to hold the axis and he has to move by applying force, manual force. There is a digital readout interfaced with CMM. This digital readout shows the selected coordinates of the selected data points, and it also shows the results. The software in the electronic system has many subroutines. We can select appropriate subroutines to calculate various features like circle, angle, straightness, etc. Manual zero setting for the three axes also we can observe. There is a touch trigger probe with A and B axis fixed to the Z-axis probe bar. This demonstration shows the measurement of diameter, angle, straightness, flatness, perpendicularity, depth, and slot width.
Alright, so this is our 3-axis measuring machine. It's ideal for measuring some machine parts as long as your tolerances aren't too tight, or laser, flame jet, water jet cut parts, those sorts of things. It's got a moving gantry, so this moves back and forth, towards and away from the operator, up and down. The touch probe has a number of articulating positions that you can lock it into. So, to do a measurement on a part like this, first thing we're going to want to do is measure the flat surface of the plane to get it aligned. Then we'll measure along an edge to get it straight. Then we'll set a point at the end, and we'll make that corner our zero location. So, I'm going to bring the probe in. Take those. We'll just stay down here. And we'll come along the edge. Take those. And stay there. And we'll take that. And finish up. Now that we've taken our features, we can go to our display. So we can take that plane that we started with, go to the readout, we'll align that, so now it's flat, and we'll make that our z-axis 0 location. We'll go to that edge we measured, we'll align that, and we'll make that our y-axis 0 location. Then we'll go to that point that we measured, and make that our x-axis 0. So now we're 0 on that corner of the part where this edge, and that plane surface come out and intersect. Now all the features that we measure are going to be taken from that point. So we'll go ahead and probe a circle here. Stay there. We can go ahead and probe a circle here. And what I'm doing is just pressing the finish key when I've taken my points, and the readout's going to figure out, based on the points I've taken, what those features are. So now we got a few features in the readout. We can come up and we can construct a circle through the centers of those two holes and that arc that we just measured. So we'll measure a circle, we'll go into our feature list, and check each one of those. So we've got 3 features. We hit finish. Now we get the circle that goes through those centers. We got an XY position for that and the diameter of that circle. Now on the part, if we want to see if that hole is concentric to this circle pattern, we can come in and check this hole location. Finish it up. And then up on the readout, we can go to a distance. We can select the last hole we measured and the hole we constructed, hit finish, and that'll give us how far that XY position varies. To measure an angle on the part, we can come down and we'll probe one edge of the angle. We'll come in and probe the other edge of the angle. And up on the readout, we'll get a display as to what that angular measurement is. We can also pull up a view and visually see what the angle is. And we can change that to, the different angle sets depending on which way our part's dimensioned. And we get varying angle measurements. When you're done with that, you can just hit the power button, hit the enter key a couple times. All those features disappear. We can check something else. So with this plasma cut part, we can do something very similar. Let's say we've got an alignment to the center line of this part. We can probe a line here. We can probe a line over here. And then up on the readout, we can create a line, select those 2 lines, and hit finish. And that gives us a midline in between the 2. Since that's going to be the center of our part, we can go to the readout view, we can align it to that, and we can zero out our x-axis along that center line. And then we can check our feature measurements to that center line. So down on the part, we can come in and probe each of these hole locations. And up in the readout, we've got XY centers. We've got a diameter for each of those holes. We can create an arc feature or a circle feature from those and find out what the overall radius is and what the center point of that is as well. So you can check odd-shaped, laser cut, or plasma cut, water jet cut parts using something like that.
And next mode of operation is motorized computer assisted CMM. In this case,